Hello everybody. So today I will talk about the system design of Bittree. So the Bittree is the service where the user can exchange the long URL with the short URL. So user can attach the short URL, let's say in the tweet, in the X, and then other users can click it, and then that user is redirected to the original URL. The benefit of this is obviously the URL is shorter, so it looks better when it is, you know, embedded in the tweet. Or maybe it's easier to, let's say, in the radio, somebody reads the short URL, and it's easier for audience to, write it down. Okay, that being said, I started with the function requirements. So as the function requirement, as I said, user can issue a short URL from his long URL. Then others, users, including others, can access the original URL when he clicks the short URL. Yep. And maybe I should say, so yeah, this is totally depends on the specification, obviously, but in this video I will talk about the custom areas. I will include it, and also user can set the expiration. So with this expiration, let's say like 1 year, after 1 year, even if someone clicks the short URL, it's not redirected to the original URL anymore. Okay, so these are the function requirements. So now I will talk about the non-function requirement. So I will start with the discussion of CAP theorem. So in CAP theorem, the system can support up to 2 of 3, which are consistency, availability, and partition tolerance. And out of these 3, partition tolerance is a must because we're designing the distributed system, and partition tolerance is a must. Otherwise, the system cannot handle the connection loss, and the system goes down, which is not acceptable. So the discussion here is which of strong consistency and availability we should prioritize, or I should say we should choose in our system. So I can rephrase this discussion in this way. So if I take the strong consistency, user can always view, when the URL is issued, immediately any user who clicks the URL is redirected to the original URL. But if it is not feasible, the system doesn't return anything. So in this case, it returns, let's say, 500 error. Yeah. Or if I take the availability, it means that, so for a while after the URL is issued, if somebody clicks it, maybe it returns 404 error, which means that that URL is not, the valid URL. But after a few seconds, that URL becomes valid. So after that, when user clicks that short URL, he is redirected to the original URL. So that's a comparison here. So in this case, I can say, yeah, I should go with the availability. because it totally finds that for a few seconds, the system, doesn't redirect the user who clicks the short URL. Yeah, even with that, I want the system to keep working rather than returning 500 sec or totally, it doesn't return anything. So that's the priority in a system here. Or maybe I can rephrase it in this way. Sorry. So if I take the consistency, it is also a case that when there is a user who submits the wrong URL, until it becomes completely ready for the short URL, for the redirecting to be ready, that request to issue the short URL is blocked, and the client has to keep the connection. In another scenario, we may have to take care to think of the strong consistency here. But of course, it is not a good idea. Yeah, the user who'd like to issue the URL would like to get the short URL quickly. So yeah, in any way, I will choose availability over consistency. Okay, so I will talk about the latency here. So of course, we prefer the low latency. So I will qualify this. So issuing the short URL, redirecting to the original URL, and yeah, these two should be done with 500 millisec. So I put this number here. So issue URL and also redirecting. So this should be 500 millisec, and I can say 500 millisec. I should say a buffer. Buffer. Maybe I should say extra, which means that we don't count the URL. Sorry, we don't count the latency which requires to open the original URL. Of course, if the original URL takes maybe 2 seconds to open the page, we don't have any way to make it 500 millisec in total. So I talk about only the extra time, which is added by this redirection. Okay, and I'd like to add one more, non-function requirement that short URL should be random and as short as possible. Yeah. So because if the URL is not random, let's say it's like number, like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, then a user can predict the next URL and they can, track, or I should say, find the next one easily. So I don't want to allow it. And also for the shortest possible, the next one, maybe I will separate them. Yeah. So this is also, yeah, quite natural to require this, obviously, because user like to, user wants a short URL, so they using this system. So definitely we should make it as short as possible. And of course, as I explained first, if this is the short URL is, let's say, written in the bold, in the road, user can easily, type it in the URL bar in the browser. So yeah, being short has many benefits. Yeah, but obviously these two are, kind of trade-off here, because obviously if we try to keep it as short as possible, which means that the other users can easily find the other URL in a higher probability by kind of brute force trying. So, but yeah, they're basically kind of trade-off. But I don't discuss the, discussion. I don't discuss the trade-off between here, but in as a tendency, I'd like to meet both of them. Okay. Okay, and I will talk about the scalability. So I support 1 billion total URLs and let's say 100 million daily active users. So yeah, in total, I'd like to support the URLs to be issued in total 1 billion. And out of this, some are clicked by, users, obviously, and there are 100 million daily active users. Yeah. Okay. So now we'll talk about the core entities. So core entities are like the database tables. So in a case, we have obviously user and long URL and short URL. These, these URLs of course include the metadata and maybe alias. No, alias is a kind of attribute of short URLs. I don't create a separate identity here. Expiration too. Yeah, so I think these are core entities here. Oh, let me just say, this one to be original URL. Okay. Good. So from here, I will talk about the API design. So I will list API names first. And my purpose here, the goal of this API design is to list all the APIs to meet these function requirements. Yeah. So firstly, user can issue a short URL from his original URLs. They should be issue, maybe create short URL endpoint. And also we need user is redirected to, this function. For this function requirement, maybe we need redirect URL API. Yeah, only this, I think. Okay, so for this one, I would say I use the post because this creates a new entity. Short URLs. In this way, short URL is created. So, and as the request body, we need the original URL and maybe custom alias and also expiration. So these two are optional. So this is a JSON body. Then this should create the wrong URL. So this should return in success case. In a happy scenario, this returns 200 with wrong URL. Yeah. But of course, if let's say this custom alias is already taken or this expiration, specified with the past timestamp, it should return 400 or something. Okay, and I don't do the authentication for this URL. I would make it open to every user. Okay, and redirect URL. So here I would say get. So there is a kind of discussion here. So should we support only the get URL or we should support post URL too? And actually there is a way to redirect non-get HTTP method request. But for this discussion, For this video, I will, persist in the get request only. So I add this get method here in the function requirement. So when user access something like http.com, no, b3.com, or maybe only b.3, and then here alias. So with this, user is redirect, or maybe I can suppose the, oh, there is another discussion here, I guess. So we should allow the add the query parameters here, but I wouldn't say I allow it here, because if we allow, if the user specifies query parameters here, it gets longer and longer. So as a specification, I'd like the user to issue a short URL which includes the query parameters, and all of them should be converted into the short URL. And when user clicks the short URL, the query parameter is included in the redirected URL. So I don't suppose the query parameter here. So with this, user is redirected to the original URL. Okay, so these are APIs. Oh, and obviously this should be HTTPS for security. But here I'd like to be, a bit more, dive deep into this redirect status. Actually, there are two redirect status here. So there is 301, which means permanently moved, and 302, this is, temporarily moved. So in case of 301, what happens is that when after the browser redirects the short URL to the wrong URL, it kind of remembers that redirection. So now when user clicks the same short URL in the same browser, it doesn't have to make this API call. And, the browser directory opens the original URL now. But for 302, as the temporary suggests, the browser always accesses this. After the redirection from the next request to the short URL, even for that, browser always accesses our server and redirects the user afterward as a result of 302 status. Yeah, so the discussion is which I should use. And I'm thinking of using the 302 here. This is because we'd like to make sure that the user accesses our backend. So otherwise, we cannot, know how many users access are redirected, or even maybe in some cases, we are not pretty sure. Maybe the redirect is not working in the browser. So I'd like to make sure that we return 302 for redirect, and the user always goes through the request to our server. Oh, and I think I should also mention that another reason why I don't use the 301 is because of this expiration. As the name permanently suggests, it doesn't specify the expiration of the redirection. So we cannot use 301. But actually, maybe I should also correct something. So I said with 302, the browser always accesses our server, but actually with cache control header, we can control the behavior of the browser. So it is possible that browser can, skip the request to the backend. But as I said, for the to correct the metrics that user requested of server, I will not specify the cache control with 302 response. Okay, so now we'll talk about the high-level design. So in high-level design, I will implement these APIs I mentioned. With that, all the functional requirements are met in the end. So here, I use the microservice architecture. The justification for that is, in the end, we need the scalability. So yeah, even though this is not a quite complicated service, I'm thinking of separating the redirect service and URL generation service, so that even if each of them goes down, the other keeps working. I mean the fault tolerant manner. So I use the microservice design. And there are two types of users here. The user who creates the URL. So let's say creator user. And there is accessor user. So when creator user, okay, so I will talk about this one, create short URL. So when user makes a request, this is API gateway routes the request into the URL generation service. So this API gateway does the routing and maybe sometimes rate limiting and yeah. So after this URL generation service accepts the request, receives the request, it writes it into the database. So I can say and in a database, obviously we need the mapping for the short URL to long URL. So I have the URLs table. Okay, so there is a discussion here. I can include short URL and long URLs in a single table, or we can create short URL table and long URL table, and long URL should have the short URL ID, so as the foreign key. But I will go with this URLs, I mean first option here, because short URL to long URL is always one-to-one, so I don't have to separate the table for now. So I will go with the simpler option. So short URL, long URL, and expiration, if user specifies that, and also alias. Oh, sorry, alias is obviously the okay, sorry, so this should be original URL and custom alias. Sorry, alias. Yeah. And this alias can be custom alias if the user, submits his preference. Okay, so this record is created. But something I have to take care is we cannot allow the collision of aliases. So I use the unique constraint here, and I will go with the PostgreSQL. So actually, there is a strong reason why I choose the Postgres for now, but I chose it just because it's an industry standard. I will update this database if there are some requirements which is specific to the feature, but for now, I use the PostgreSQL and I put the unique constraint, and that's enough. Yeah. Okay. So now the next function requirement, redirect URL. So I intentionally separate the service here. So this is basically for the fault tolerance. So even if this server dies, URL generation dies for a reason because of, let's say, the memory leak, I want the URL redirection service to keep working separately, independently. So I separate the service here. And also, maybe I should talk about the access pattern too. So URL generation service, I can say this is very steady access pattern. But for URL redirection service, let's say the Taylor Swift posts the URL, shortened URL, and that tweet is seen by so many people. In that case, the users who saw the post immediately accesses that short URL. So there is a spike. So I want this, again, I separate them because of this reason. Because, yeah, I don't want that, I don't want to allow that redirection spike affect the URL generation feature. Okay. So the request is routed into this. And now what happens is this kind of fetches the recode according to the alias. So we need the quick fetch from quick lookup from this alias. So we need the index here. So with this index, the query can access this alias specified in the login time. Okay, so this is it. So something I have to mention as a function requirement is the expiration. So there's an expiration here. So how can I support that? So what I can do is, when user makes a request of the when user accesses the redirect URL, with this fetch query, we can specify like where expiration is null or expiration is before equal to the current time or before. So with that, where cross, I can filter. I can, we can redirect the user only if expiration is, not, valid. Now or before or not specified. Okay. And maybe if the database is too big, grows too much, I can delete the records with outdated expiration, but I will talk about that in terms of the scalability later, maybe. Okay, so I think now I've met all the function requirements. Yeah. Okay, so that being said, I finished my today's system design practice with this. So in the next video, I will talk about these 3 non-function requirements. How I ensure that short URL is random and short enough, and also how I can scale the system. Okay, thank you so much. Bye.